Okay, students, in the last video we have learned about the factors affecting the movement of ocean currents. So in this video we'll be learning about some major oceans of Atlantic Ocean and Pacific Oceans. Okay, although there are other ocean currents in other seas and oceans, but we'll be discussing only about Atlantic Ocean and Pacific Oceans. So here we'll be discussing about the warm current and the cold currents of the Pacific and the Atlantic Oceans. So areas to the east and the west of the Atlantic are well developed. It is due to the warm and cold currents that develops on the eastern and the western margin of the continent, and due to it has a greater impact on the trade and transportation, especially along the eastern and the western margin of the Atlantic Ocean. Okay, so let me show you in the map. Okay, here we are particularly discussing about the North Atlantic currents, okay, or the North Atlantic Ocean especially. So the western margin of the, say, Atlantic Ocean and the eastern margin of the Atlantic Ocean is well developed. It is due to the warm and the cold currents that develops along this region. Okay, so it is developed in the field of trade and transportation both. Okay, so currents, ocean currents help in the trade as well as transportation. Now coming to next, we'll be discussing about first warm ocean currents of Atlantic Ocean. So which are the warm Atlantic Oceans of which are the warm ocean currents of Atlantic Oceans? So starting with first one, that is Florida current. Okay, now Florida current, this is important. Florida current flows from Strait of Florida to the Cape Hatteras. Okay, now strait is simply a narrow channel of water that separates two land masses. Okay, so from Strait of Florida to Cape Hatteras, Florida current flows, but its source means it originates from the source of Gulf Stream is Florida current, we can say. Though Florida current originates in the Gulf of Mexico, but it is named after the peninsula of Florida. So this current along with Gulf Stream was first discovered by uh, Ponce de Leon in 1513. This is important. Ponce de Leon. Both Gulf Stream and Florida current was discovered by Ponce de Leon in 1513. Okay, so remember this. Florida current flows from Strait of Florida to Cape Hatteras. Okay, although it originates in the Gulf of Mexico, or it has a source, it originates from Gulf of Mexico, but it is the name is kept on the basis of Florida, peninsula of Florida. Okay, now coming to next current, that is, okay, we'll see in the map first where is Florida current, where it originates. Okay, here. Now this is Florida current, curved one. Okay, so it this is a peninsula of Florida. So from here it originates, and this is Gulf of Mexico. Okay, down. So from there it originates and it moves towards the northward direction. Okay, now coming to next. Now you can also see the cross section that shows the movement of different warm ocean currents in the Atlantic Ocean, starting with Florida current. It flows from Strait of Florida to Cape Hatteras. Then next, immediately followed by Florida, is Gulf Stream that flows from Cape Hatteras to Grand Bank, and from Grand Bank to West Europe, North Atlantic Drift. This is also a warm ocean current that flows towards the northeastern side, towards the West Europe. So we'll be discussing one by one about all these ocean currents. Now coming to next, Gulf Stream. Now, Gulf Stream is very important. Why? I'll be telling you the reason behind this. It flows from Cape Hatteras to Grand Bank. It was also discovered by Ponce de Leon in 1513. So it is a warm and very wide and is separated from the relative cold water that develops near the east coast of USA, which is also known as cold wall. Okay, so to the left and Sargasso Sea towards the right. Let me show you in the map, in the figure here. Now you see this is Gulf Stream, movement of Gulf Stream. Okay, now in between this like just toward the western side of Gulf Stream we have uh, cold water, that is we call it as cold wall. Okay, or you can say it separates the Gulf Stream by cold wall or cold water. Then towards the right you have Sargasso Sea, right of the Gulf Stream. Okay, okay, coming to next. Now, okay, here. So the Gulf Stream generally follows the coastline, but deflect towards the east at 40-degree north latitude. That this is due to the rotation and the westerly impact, or due to the westerly wind. Now, Gulf Stream generally flows towards the northern direction, but when it reaches towards the up to 40-degree latitude, from there onwards it deflects towards the east. Okay, and this is because of rotation of the earth and the movement of the westerly wind. Okay, now westerly wind blows from west towards the east, so thereby along the direction of the westerly wind the ocean current also flows towards the eastern direction. Now coming to next, after crossing 40-degree latitude longitude north latitude, it mixes with cold Labrador current. So this results in the formation of dense fog. Now this is very important. Many times it is asked in your final examination or in the board examination. Okay, why a dense fog is developed near 40-degree near Newfoundland? Okay, the reason behind this is uh, it is a region where warm current and cold current meets. So due to the mixing of this warm current and cold current, a dense fog is developed. Okay, so here, so that is mixed with cold water, cold Labrador current coming from the Baffin's Bay. This results in the formation of dense fog near Newfoundland. So this creates problem for ocean transport due to low visibility. Okay, now this is the reason why transportation, there is a problem in transportation nearby Newfoundland, because this region is a meeting place for cold Labrador current and warm Gulf Stream. Okay, so this will reduce the visibility. Now coming to next, Gulf Stream is responsible for modification of climatic condition of the east coast of USA and the west coast of Europe. Now you this you see this image first. This side we have, this is the east coast of USA. So this is the climatic condition of east coast of USA, and this side you have west coast of Europe somewhere else. So this west coast of Europe and the east coast of USA is affected due to Gulf Stream. That means the climatic pattern is affected by the Gulf Stream. Okay, so we'll be discussing how it is affected, in what condition. You see here. Now temperature during summer is high in the east and southeast of USA due to onshore wind, but during the winter it does not benefit as the wind blows from the land. Now look at this diagram now. Now look here, during the summer season what happen is the wind, onshore wind, that is wind blowing from the sea towards the land. So as there is movement of Gulf Stream during the summer season there, okay, or even in the winter season it blows in the same direction, but here the wind blows from the sea to the land. So in that case a Gulf Stream is already a warm, so it will try to increase the temperature. Due to the warmness of the water, the hot air blows towards the land, so thereby the temperature of the east coast of Europe will increase during the summer. But during the winter, what happened, although there is Gulf Stream, but the wind blows from offshore, that is it blows from the land towards the sea. So that means land is already cold, right? But there is no benefit of Gulf Stream during the winter, thereby the east coast of Europe remains frozen or remains very cold. Okay, temperature drops down during the winters. Okay, now coming to next. Okay, so this is all about Gulf Stream. Now we'll move toward the next topic, that is North Atlantic Drift. Now North Atlantic drifts, as let me show you in this particular image. North Atlantic drifts, uh, yeah, it flows from Grand Bank to western part of Europe. Okay, especially the countries like Norway, Sweden, France, etc. Now let's see one by one. The North Atlantic Drift is formed at 45-degree north latitude, that is near the Grand Bank, where the cold Labrador Current joins the warm Gulf Stream. Now, so generally the meeting place of Gulf Stream and Labrador Current is the place where the North Atlantic Drift originates. Okay, so here uh, from there, means from Grand Bank, okay, it from Grand Bank towards up to the west of the Europe, it migrates up to the west of the Europe. Now, though the temperature, salinity and the velocity of the Gulf streams are reduced slightly, the North Atlantic drift retain the main characteristics as warm currents. Now, we have already discussed about the mixing of the cold current and the warm current. Okay, so when this Labrador current and this say when this Labrador current coming from the Baffin's Bay and the Gulf Stream meets in this region, okay, then what happened? The temperature of the water will reduce to some extent, but the same stream will retain its warmness. Okay, it is still a warm current, although the temperature, salinity, or velocity of the stream has reduced, but it will retain its characteristics, means it will maintain its characteristic as warm current. Okay, then it starts flowing towards the eastern direction. Now you see. Okay, now the North Atlantic Drift is further bifurcated into two branches. The one branch of North Atlantic drift moves to the Norwegian Sea along the coast of Norway. Okay, and the another branch comparatively warmer than the prior one, means the first one, due to the less mixing, move eastward and flows along the coast of France, Spain, Azores Island, etc. Okay, some part of the trip enter into Mediterranean Sea and Bay of Biscay. Now look here, let me show you in the map first. Look in this map. Now here uh, okay, now this is North Atlantic Drift current. Okay, so which is bifurcated into two division. One moves towards the Norway, along the Norway, okay, and the other one moves towards the southern side. One moves towards the northern side, okay, and one bifurcates in the southern side. So one blows towards the coast of Norway, and other blows towards the region of France, Spain, Azores Island, etc. Okay, but the downward or the southward current ocean current is quite warmer compared to the north one. Okay, okay, let me show you in this way because it's not visible from there. Now this is a North Atlantic drift current which is bifurcated into two parts here, mainly two parts. Okay, one moves towards the Norway. This is Norway, along the coast of Norway, and the other one moves along the coast of France, Spain, and etc. And one more branch of this North Atlantic drift moves towards the south and flows along the coast of Biscay, along the Mediterranean Sea, and along the coast of Africa. So in this area region, it flows in these areas and becomes the part of Canary currents. Okay, now coming to next. Okay, now, okay, look here first in this image. So this is North Atlantic drift. From here it originates and moves towards the eastern side, and one branch moves toward the north along the coast of Norway here, and one branch moves towards the coast of France, Spain, and Azores Island, and one more branch moves towards the south down. Okay, and flows along the coast of, some branch moves towards the Mediterranean Sea, and one branch flows along the coast of Africa and becomes the part of Canary currents. Okay, so this is how the North Atlantic drift move in different locations. Now coming to next. Okay, so in this video we'll be discussing about only warm current first. In the next video we'll proceed towards the cold current.